before, I'm the VP of Engineering here at Deus. So I am taking Gabe's shoes and emceeing this event right now. I actually wanted to kick off this community-centric event on a discussion about something that Barry Mack brought up in the Slack community channel this morning. And it's a Circle CI blog post that I found very amusing. I'll paste that in chat so you can take a look at it at your leisure. Hold on, having copy and paste problems because I switched my keyboard and all the keys have changed. There you go. So I'll just outline kind of what that article talks about. It's kind of discussing how the complexity underneath just getting an app running is overwhelming. We've gone from configuration management world with tools like Puppet and Chef all the way to, hey, here's a container, just run it, and then, oh, there's a lot of complexity around running multiple containers of the same type, networking complexities, all sorts of things in that realm. And you really have to keep your head on your shoulders and keep learning all these interconnected components to be really excellent at your job, whether you call it a DevOps engineer, a DevTools engineer, an SRE, or whatever that is. And we actually pulled Deus Workflow through one of these transitions recently and kind of went from a stack of technologies like etcd and Fleet and all these CoreOS style primitives with Docker, and pulled it up a level, hopefully making it a little bit less complex to understand. But really all those things are still there. etcd is still there, but just under the Kubernetes umbrella now instead of the Deus Workflow umbrella. And so we kind of, in that operation of replatforming, we went true engineering style, went dark, and went into our coding caves, which this is my coding cave with lots of limited distractions, and really tried to hammer this thing out and make it useful and more stable. We have kind of accelerated the amount of features that we're able to deliver to Deus Workflow out to you all. But we kind of went dark from a community standpoint. So I am always looking for ways that you're using Deus Workflow or one of our other projects, Kubernetes Helm, in your companies, in your workflows. And so if you have something that you're really excited about how you're using wiring up CI or CD integrations into workflow right now in your organization, let me know. I am S-Goings on the Deus community Slack. And I think I'll be reaching out to a few of you that I've seen kind of toss up some interesting ideas so that we can get some demos of things that you all are doing with Deus Workflow instead of just being a demo of something we're doing internally or just kind of a review of our roadmap. So yeah, let me know if you come up with something. I think I was also talking to Helgi, who is also on this call now, who is a recent Deus departure, but still wants to get involved in the project. I've been talking to him about ways which we can make the things that we talk about on a daily basis or weekly basis a little bit more accessible to you all, such as doing like a public stand-up or something like that. So with all of those ideas, reach out to me on Slack if something I just said piqued your interest. If not, I'll just actually continue this presentation off to Jason Hansen, who will talk about what we're thinking about producing and what we're doing recently with workflow from a feature standpoint. So take it away, Jason.
Hey, thanks, Seth. I'm having camera issues, so you get the side shot. So I want to be looking at all of you, but whatever. Thanks, computers. So I just wanted to go through what we've done with Workflow 2.5 and 2.6, which are the releases that we shipped since the last community meeting. In case you didn't catch those those release notes. In 2.5, we added auto scaling. That is powered by horizontal pod auto scalers under the hood. So we're pretty happy, again, with the ability for the team and the community to get new feature functionality based on the engine of Kubernetes. So I think it's one of the things we were able to surface pretty effortlessly. A big shout out to community member Jaron Visser. He added capability to the builder component to cache build results, which will speed up subsequent Git pushes after the first build. So that's for the so that's good and a great community contribution. Appreciate that. On the application front, TLS may now be enforced on a per application basis, so you can toggle that per app rather than previously it was once you enabled TLS, the router component required all apps to be HTTPS. Again, on that per application front, we've added the ability to do IP whitelisting per app. So those commands have been added to the Deis CLI to make sure that you download the latest version to get access to those. With respect to 2.6, there was a lot of small bug fixes and maintenance work, a lot of cleanups, less feature heavy, but still important stuff. In FlexDB and Telegraph, we're both bumped to the 1.0 release versions. So if you haven't checked it out, Grafana.yourcluster hostname has a set of charts and graphs that we deploy automatically alongside workflow that allows you to monitor the health of the workflow components. Another big shout out to community member Rob Holland submitted some router changes that allow passing through X request ID and X correlation ID headers. So if you're using tools that depend on those, you should now see them, which is good news for that tool. As well, thanks to Felix Beneman for submitting fixes for a Builder plus proxy protocol. So if you're using ELBs with proxy protocol, Builder will now actually work for you. As well, we also bumped the Deis base image, which includes OpenSSL CVE fixes that came out a couple of weeks ago. That Deis base image is the from line for all of the various workflow components. So we then went through and bumped all of the rest of the components to include that fix. Up next, as Kubernetes Helm is approaching its beta series, we've been working on porting the charts from Helm Classic. This work has been spearheaded by Kirthan Malla, K-Malla, hanging out on the community channel as Deis employee and engineer. Those charts can be found at GitHub, and I'll shoot this over in chat. So these are Kubernetes Helm compatible charts. So if you'd like to follow along, there are a couple of GitHub issues under Deis charts where all of our work is happening there. For the foreseeable future, we'll probably be releasing, or we will be releasing Kubernetes Helm and Helm Classic charts in parallel. So I don't expect to be abandoned in that regard. We'll be working on the upgrade story between the two Helm versions as well. With 2.7 as well, we've got a few more things that we need to do, cleaning up and automating the rest of our release process, both for individual components as well as the release process and automation around our base images. I think we've learned some things bumping it last go around, help make the project a little bit more efficient. As well, we have a number of feature or issues, GitHub issues that are tagged with the 2.7 milestone. So there's a bunch of tweaks and cleanups that are staged and ready to go. That's 2.7. And the release date should be in a couple weeks. Anybody have any questions on that? As well, release notes are shipped to the documentation site, the complete release notes with all of the commits. That's a new addition, as well as the release blog posts that add a little bit more flavor and flair to what we're doing up on the Deis blog.
Yeah, and then it looks like Remus had a question in chat. What is the upgrade option for workflow when it was installed with Helm Classic and you want to use Kubernetes Helm moving forward? We're actually talking about that kind of right now, so we don't have an answer to that right now, but hopefully it's something easier than slogging through a couple essays worth of documentation. At this point, I actually want to hand it off to Jonathan Chauncey, one of the Deis employees, who has been related involved in a lot of the CI/CD work that we do for all of the Deis components. So Chauncey, take it away.
All right, how's it going? Let's see if I can share my screen. I cannot. Seth, you may have to give me that permission. Or Jason.
All right, go for it.
There we go. There we go. Perfect. Okay, I'm on a very large monitor, so if somebody, it may look a little weird for people on laptops and stuff. I apologize. So I'm going to talk about kind of how we do, kind of what the behind the scenes looks like for the continuous integration system, kind of how we package PRs and how we test them and how we go through this cycle and kind of our journey and how we've gotten to this point. Most people, I think we've talked about this before. I didn't pull up this tab. We actually have we have a Jenkins job repo that's public. This is where we document and we do all of our configuration for our Jenkins jobs. Feel free, if you see a problem or an error, to come, with a job. If you don't think if it's not working right, or you feel like there's probably a more efficient way to do something, we would gladly take pull requests in this repo. But we do all of our configuration for Jenkins through this. It's broken down by like components. So you can see we have a components task, and that basically is what spins up all the jobs for a given component. So for example, this is what creates the base level job, the master job, and the PR job for each component, and we basically just iterate over an array of all the components we have. It's pretty straightforward, but feel free to get your hands dirty in this if you want to learn more and kind of see how we do that. But that's really the high level. This is how we configure everything. So everything you see that I'm going to show in Jenkins comes from these set of scripts that we have here. So back when we first started the workflow task, how we were porting over to V2, we knew this was going to run on Kubernetes. The biggest problem we had was how do we test that Deis is actually good? How do we do that? And we knew that there was going to be some end-to-end testing involved, which meant we needed to stand up a Kubernetes cluster. So Seth went through and created basically a set of scripts that could reach out to GKE. It could provision a system. It would get all the credentials. It would install Deis on that cluster and kind of get everything going before we kicked off the test. And all that happens in a set of jobs called like Workflow E2E and Workflow E2E-PR and Workflow E2E release. And so these jobs, they did all this work up front, and then they kicked off the tests. And the problem we had was that spinning up that cluster was a lot of work. It took a lot of time, and that meant that our end-to-end jobs would run for like 30 or sometimes 45 minutes, because it would take 5 to 10 minutes just to provision a cluster, get it in the state we want it before we could even start running tests against it. So this had a really great benefit of that we had this on-demand capacity. So as many jobs as we could potentially run at any given point we had a cluster. We just spun it up. We didn't have to wait around for a cluster to become available or something like that. We created one on the fly, but we paid for it in that time. So after a while, we realized this really wasn't a great tool, a great way to handle this. And so we created a new project called K8s-Claimer. This is also public, so you feel free. Everything I'm talking about today, you guys can go investigate. You can use this in your own CI systems. But this allows you to lease a cluster from GKE out of a pool. And you can configure it with a set of environment variables. So it looks for things like the namespaces and service names, and it has an authorization token and things like that, where K8s-Claimer's running, stuff like that. It's pretty simple and straightforward. It has a project ID, so this is basically where the pool of clusters live. So we have our own project where all these end-to-end leasable clusters live. And so this tool has an HTTP endpoint that you basically asked for a lease, and it gives you back a token. You lease it for a specific amount of time. It gives you back a token and essentially the kube config, so you can talk to that cluster. And this was really great because it moved us away from being having to provision these clusters on demand all the time to having a more static set of hosts. And so it sped up the build. We immediately gained a good chunk of time off the front of the build. Now that we could just say, hey, give me a cluster, and it would immediately reply back, okay, here's your cluster, and nobody else could get that. So that was great. We immediately chopped off 5 or 10 minutes off our build runs. And there's another project that kind of ties into that, and I'll talk about that in a minute. But what we realized is that we were running the tests all in serial, because that was just how the end-to-end tests that we ported from DSV1 to DSV2, that's just kind of how they worked. So we went through a lot of heartache and tribulation to parallelize these tests. We were lucky enough that we were running these all in Ginkgo, which has a very user-friendly parallel test run. Hold on, I gotta close this window. It allows you to run these tests in parallel, and we spend a lot of time working on parallel tests infrastructure. So I want to talk about this a little bit, and kind of this is where we spend most of our time, is dealing with the fact that we run these tests in concurrently, and it causes a lot of problems. So if you go and look at a workflow test PR job, let's see. Well, if I can find one. So these tests, we run them in parallel. When you run tests in parallel, you get test poisoning. So we had to work on being able to create apps in parallel, create users in parallel. And so we created a lot of shims that allows us to handle that. I was trying to see if I could demo some of this, but I don't know if I could find it. But basically, we need to be able to create a user, assign it a unique identifier, and also be able to create a new app under that user. So basically, we can queue up these users and apps as we run through the tests, and we're never having to wait for them. We're just spawning them as we go along, and you basically just grab one and you keep right on trucking through. And we find that our end-to-end tests, and if you've ever submitted a PR, sometimes you realize, oh, why, I just had a seemingly random test fail. It wasn't anything I had, that had to do with me or the code I was touching. It just, something happened. And this is part of the problem we have with our CI system. I think anybody that's ever written end-to-end tests will also vouch for this. You have these interactions, and you kind of can't control, like, networking, like, oh, I have to reach out to something else, and it took too long to talk to that system. And so we're in a constant battle of like making sure we have the right timeouts, that we have the right the right interactions for all of these tests. So that being said, we worked really hard, and we've come a long way, and our stability has gotten really good over the last couple of months. But we definitely have a long way to go, and would like to improve more on that structure. So I'm gonna go back. Let me look at my notes real quick, make sure I'm talking about everything I need to. So that gets us to where we are. So we basically started cutting down the time on the test. We started parallelizing these tests, and I kind of talked about that in the past. We went from basically being able to make a test run in 30 or 40 minutes. We're now down to like 10 to 15 minutes for a given test run, depending on how many threads we throw at it. We realized also that we needed to slow down. We needed to reduce the number of threads to increase stability. The faster we tried to push the system, the more threads we threw at it, the worse it got, the more instability we had, the more flakiness we had. So people ask me all the time, how do we run these tests? So I don't want to talk about the test suite. They're kind of boring. They just drive the CLI. There's not much there. But how we actually run them is actually really important. And these actually run as a pod installed on the same Kubernetes cluster that the Deis cluster that we're testing against. So if I look down here, there's actually a test running, so we can check this out. Workflow test PR. So to step through this real quick, you can kind of see and ignore this. We're in the process of changing some stuff, and these jobs are spitting out some gobbledygook from GitHub. So basically, what happens in a test run is we lease a cluster. So you see here, we asked for a cluster. We have a project that does that called end-to-end runner. So end-to-end runner is the thing that encapsulates an entire end-to-end run. It is used in a couple of different jobs. So end-to-end runner has all the necessary tools to run these end-to-end tests. It has kubectl, it has the Deis CLI, and things like that. It can actually talk to these different cluster components. So the end-to-end runner says, I want to request a lease of 1,600 seconds, and then it immediately got back Bouillard. All of our clusters are named after champagne houses in France. So this is the 5-node cluster. They are N1 standard 4s, so they're 16 gigs of RAM with 4 CPUs, virtual CPUs. And so it said, give me a lease. It immediately gets one back. And we print out how many nodes there are, status. Basically, we get that information back, and then we immediately proceed to install Deis onto that system. So we actually use Helm, and we install the workflow dev chart. So if you've ever gone and looked in Deis charts, you'll notice this chart here. This is what all the developers use locally. It basically points everything to a canary image. So as PRs emerge, we know we're always up to date. We're always pulling down the latest. But what can be really interesting is when, let me pick a slightly different job that has, it's actually we'll pick a failing one. So this will be interesting. So when when a pull request is triggered by this job, we actually inject into that the image that is resulted of that PR. So before a couple of builds or a couple of jobs ahead of this, we actually built this image and uploaded it into our remote registry key. And so we're going to use that as part of this test run. So we have some logic that allows us to able to figure that out and insert that into the chart at install time. Let me pull up the chat so I can catch questions. Oh yeah, my scrolling is probably pretty bumpy, so I'll try not to jump around too much. Sorry. So as we install the chart, we're constantly health checking it, making sure that it comes up. So we poll until we know that all the pods are done, all the pods are ready to go. And if at any time a pod is in a crash loop or errors out, we immediately halt and say this test run is bad and we fail to build. In this particular case, all the pods came up, they're all running, they all look good. So now we need to actually see if Deis is okay. So we try to interact with the router 10 times, and this is a configurable number. We said 10 times because that we sometimes have a little bit of time for the router to get configured to pick up all the annotations and everything that's gotten deployed. So at that point, we're interacting with Deis. Okay, we're good to go. Everything's fine. We say, hey, by the way, if you want to watch this run and look at the stats, if you want to look at the monitoring output, here's where you can go and do that. We then proceed to actually install the end-to-end chart. So if you've ever looked at the Deis charts repo, you'll see there's a chart called workflow E2E. And this E2E chart, or workflow dev E2E, this end-to-end chart is how it contains the image that actually runs the end-to-end tests. So we do the same thing. We install that chart using Helm. We wait for everything to come up. We say, are the pods that I expected to come up, are they ready? Are they available? And they are. And part of that chart, or part of that pod, when it comes up, it actually installs the local Deis CLI, the latest it can find. And we can also pass into this value another version. So we can use this same pod to test CLI changes. So if somebody submitted a CLI PR, it would actually build that CLI and then test it here as part of our pull request policy. So we know that the CLI, the things that they're changing, are valid against the end-to-end tests. At this point is where we start seeing some flakiness. And if you go and I won't do it right now, but if you actually go and look at previous builds we had last night, you will notice that we will sometimes not be able to talk to like the Google API storage endpoints. So they just fail for whatever reason. we're not actually sure if this is a GKE problem or if it's just some type of rate limiting by IPs or what's actually occurring. But for 4 or 5 runs in a row, you may not ever be able to download the CLI. So this is an ongoing issue for us. We've actually reached out to Google a couple of times to kind of figure out what's going on, and they don't ever really have a good answer for us. But it's something we're fighting with. And if you ever see that problem, just know that, yeah, we're aware of it, and it's definitely it's terrible for us. We'd rather have passing runs instead of relying on third-party systems. But so we reach out, we get the CLI, and we move forward. We actually dump out a lot of information. This is just debug stuff that's been left over from us trying to track down flakiness related to not being able to download the CLI. So we scroll down, we'll start to see that we print out what version of the CLI we're using, and we move on. And so here you actually see the Ginkgo command we're running. So we have a slow spec threshold of 120 seconds. I sometimes think this is kind of low, but because it gets pretty noisy. We say we want to run 15 parallel nodes, and we're going to skip all tests that are related to build, pack, and Dockerfile apps, and then we give it the test suite, the test directory to run in. And so then we just get the output. So it's pretty simple after this. It's pretty straightforward. Our tests look a lot like RSpec. Ginkgo is a behavior-driven model, so it's very akin to the RSpec model. We find it reads really well for what we're doing these types of tests. It allows us to do contextual tests and things like that, similar to what you would do in RSpec. I'm going to scroll to the bottom, so this may not come up pretty quickly, but we have we actually use the build error regular expression checker thing, whatever it's called. I can't think of the name of the plugin right now, to look for common error cases, so we can kind of track those. In this particular case, we're looking for unknown error, and whenever we see an unknown error, we basically mark that so we can track to see how many of these we get. Normally, it's related to something around networking. I would say good 80 or 90% of these are related to some type of networking issue. But in this case, we failed because we were unable to create new content in a namespace because we were deleting the namespace from up under itself for whatever reason that was happening. So go to the bottom. So as these tests run, it's dropping all this out, all this standard out, and all the things about the pod, what's happening. All this is getting logged out and archived and onto the host. And then we pick that data up and we shuttle it back to our Jenkins host. So this is happening in GKE, and all of the CI system itself is hosted in AWS. So we basically exec into the running pod. We have a sidecar pod that's capturing all this log data. We basically exec into that and shuttle all that data back down to the host, and we write it out so we can collect it and analyze it if in case there was a build failure. And so that's what you're seeing here. Where we retrieve the JUnit XML file. We check to see what are the pod exit codes. So for instance, the test pod exited with a code of 2, but we retrieve the artifacts exited with a code of 0. And then we go and we gather all the pod logs. We clean up after ourselves on this particular cluster, on these particular runs. So we uninstall the workflow dev chart. We delete all the namespaces, so we clean up any lingering test namespaces that might have been available. We give the lease back to the system because we lease it for 1,600 seconds. That's actually longer than the test run. So we want to make sure we delete the lease afterwards. And then we do a couple of things to help us notify or help us know what the build was about. So this was a controller PR number 7731. And then we just do normal archiving of artifacts. And then we obviously publish this stuff into Slack and other, the GitHub issue and things like that. So that's what's occurring here. So we've definitely come a long ways from where we started, which was we run these tests in serial. We were provisioning clusters on the fly, eating a lot of time doing that. And now we can run a test, and this test took 22 minutes start to finish, which is really good because as we add more tests, these tests are going to grow in time. So it's probably actually time we probably actually should start spending time on increasing the parallelism. We probably should try to go from 15 nodes to 20 or 25 parallel tests running at one time. And so we can speed this up, maybe drop it back down to 15 minutes or even 10 minutes. So that's kind of a high level overview of the workflow tests. I didn't want to go too far in depth. I know that there'll be a lot of questions in the community channel later. One other thing we realized was we needed a way to provision clusters at night, or basically during the day, and then tear them down at night. We didn't want clusters just hanging around in GKE, not doing anything, and basically wasting money. So we created this project called Clusterator, and it has a create endpoint and a delete endpoint, and basically not endpoint, a create command or delete command, and it takes has a list of possible names, and it just spits out X number of clusters given some machine type and a zone. And so we have a job that runs in the morning, creates 10 new clusters, and at night it tears those 10 clusters down. And then we always keep around 5 or 6 static clusters for when somebody's working late at night or on the weekend, they have some availability. And so all these things are open to the public. You can feel free to go look at them, comment on them, open pull requests or issues, or ask me about them. We feel like they're pretty useful for us, and maybe other people would too. There's lots of neat things you could do between Clusterator and the K8s-Claimer, like tying K8s-Claimer into Slack, so you could potentially say, have a bot that'll lease a cluster for you that provisioned Deis on it automatically. So somebody can say, just give me a Deis cluster for 15 or 20 minutes, and you could go run some tests instead of having a full-on staging environment. Let's see. There's just, the sky's the limit with these kinds of tools. So that's pretty much all I've prepared. I went through this pretty quick. I didn't know how much time I'd have. So if anybody got any questions, I'll answer them now, or you can hit me up in Slack.
Yeah, if you have any general questions too, just make a comment in chat and we can make sure you get the floor. Silence. I always found that the more introverts you get in the room, the less likely it is to get questions raised. So Clusterator is private. Chauncey.
Oh, that might be. Let me. There is nothing in this that should be. Let me check it out. If it is private. Oh, it is private. I will make it public. Let me make sure there's nothing in it that we don't care about, but this should be public. It might have been an oversight on my part. Sorry.
Well, with that, we are always available in the Slack community channel. So if you ever want to follow up with me on my requests of making this community more inclusive and more engaged in our weekly feature development, or kind of our CI/CD development that Chauncey just presented, just feel free to reach out there. With that, I think that leads us to the end of this community meeting. So see you all on the interwebs.